Okay, so now we'll be looking at how this k-means clustering work algorithmically. Okay, so we'll be looking k-means each and every step in detail. First step in the process, so we'll start at how we'll find elbow point. So what is elbow point? This is nothing but the basically value of k we'll find through a graph or through a methodology that is called elbow point. Okay, next we'll be measure the distances, and after that we'll group based on what minimum distance. Then we'll reposition the centroid. After that, if we'll make a decision, have the centroid repositioning have stopped. If it is yes, then will convergence has occurred and we'll stop our process. Otherwise, if it doesn't happen, what we'll be doing, it is unstable, so we'll go and measure distance again and we'll iterate through this process. Okay, so let's look at a live example of it, how it's working. So let me show you a live example of it. So consider an example of a grocery shop example. So what grocery shop example contains, that it contains some of the data regarding to your employees, not basically employees, customers. Okay, so what customers are doing is that you have customers, you buy certain kind of products, and based on that you have to cluster your customers, that whether they are buying or not, which kind of product, and which all interest their interest lies in. So this kind of thing you can do with the clustering. You can cluster the customers based on the input. So that thing we'll be exploring here only. Okay, now, so just have it, let's say consider this is our data set. This is our data set. This is our data set, and you want to cluster it. Okay, now what will you doing? Firstly, you will be deciding what is the value of k. First question that should come to your mind, that is what is the value of k. This is the first question you have to ask yourself according to the algorithm. Here, what is the k? So how will be finding the k? There is one method that is called elbow method, and this is very important method in finding the value of k. Elbow method. This is very important in finding the value of k. So how will we doing? There is something called weighted, what we say, within sum of squares. There is something called within sum of square. It will be helpful in finding the elbow. So let me first write down the formula of within sum of squares, that you can represent by WSS. That is summation I equals to 1 to m xi comma ci whole square. And how you will be defining the least value? You will be doing what? The thing, the value of k whose WSS is least, you will be using it as the k value. So here x is a data point and c is the closest point to centroid. This is nothing but the closest point to centroid. Okay, centroid. How I will be doing this? You will pick out the values of k as 1, 2, and up to whatever value, let's say 100. Okay, you will be calculating the distance of each and every point with these centroids. Okay, and after that you will be finding that there will be curved form like this. This is for value of k's. and this is the this coordinator print WSS. And you find that after a certain point, uh, your K value, that WSS value, stops reducing. So this is called elbow, and that value will be optimal. This is their optimal K. Optimal K. This is how you will find the K value. Okay. Now next, what we'll be doing? We have to measure distance. Let's say this is your data set. We have to measure the distance. Measure the distance. And how will you be measuring distance? You will be using something like either Euclidean distance or Manhattan distance. So generally we use Euclidean distance in most of the scenario, but it may vary from situation to situation, and we'll be then assigning some centroid. Let's say we assign centroid this. This is a centroid. Okay. And let's say that is another centroid here. Now, next is that based on this centroids, we'll be clustering our inputs. So here we go and clustered. Okay. Now, next what we are doing? Next thing we have to do is to reposition the clusters, reposition the centers. So how we can do? We can calculate the average and we'll reposition the cluster. Let's say the new cluster comes here and here. Okay. Now, based on this new point, if let's say there was some point here and it was initially here, and later on you find, okay, this is not close to this, this is close to this, so you'll be taking it into that cluster. That's very simple. Okay, so this was all about the k-means clustering algorithm. Okay, and next video we'll be looking at the practical implementation of the k-means clustering. Thank you.